everyone. So for this project, I set up 5 different virtual machines inside my VirtualBox. So these VMs are Windows Server 2022, which I used as my domain controller, an antivirus server, which is also running Windows Server 2022, 2 different Windows 11 clients, Client A and Client B, and an Ubuntu VM for running FreeRadius server. So each of these VMs are run on the same network adapters, which is 2 of them. One of them being the NAT adapter so that it can have access for the internet access. And the other one is an internal network that I personally set up so that all the VMs can communicate with each other on the same network that I set up. It is called Lab Network, and you can see across all the VMs, it is consistent Lab Network, uh, Lab Network, Lab Network, and Lab Network. And yeah, that's all for the setup really. Okay, so starting with scenario 1. For scenario 1, I did a certificate-based authentication using FreeRadius server with EAPOL TLS. EAP TLS, my bad. So let me first show you that I had properly installed FreeRadius onto my Ubuntu and that it is properly running. So the FreeRadius and 5. As you can see here that it is active and it is running. So that means that I had properly installed it onto my Ubuntu. Now let me show you the certificate files. Wait a second. Client pen, client key, and client set. Okay, so yeah, here are my certificate files. These were generated by our own certificate authority on the FreeRadius server. So it says there that client PEM is basically our client certificate. Client key is our private key, and client cert is just a certificate but in an alternative format. And all these certificates are issued are identity specific and issued by our CA specifically for client A. Client B will be a different thing that I'll explain later. Let's first of all verify these certificates real quick. So we'll verify it against the CA file. So you can see there, CA, and then we'll verify our client against the CA. And as you can see there, it says okay, meaning that it is signed properly by our CA, and therefore the certificate chain is valid. So now, first of all, let's run, let's stop FreeRadius server because we want to run it in debug. And the first thing you need to do is to stop the FreeRadius server first, okay? It should be stopped now. We can just check it real quick if it has stopped. And yes, you can see there's inactive or dead, meaning it has been stopped. So what I'm going to do next is run the FreeRadius in debug mode, specifically in the background. So you'll see here that debug .log. I'll save it as a log so that we can see it later, like the server side logs. Oops, my bad. So you can see there that it shows that it is basically running on channel 1 in the background. Let's do EAPOL test now. So I'm using EAPOL test to simulate Wi-Fi authentication or authentication via certificate over Wi-Fi. The reason why I'm using EAPOL test and just simulating it instead of actually using like real Wi-Fi is because VirtualBox cannot access my host Windows's physical Wi-Fi card because that requires like the native OS control. So I tried working around it by using a USB Wi-Fi adapter, but my drivers were not compatible with my current Ubuntu kernel. I tried many different things, and in the end, I'm pretty sure the only way that I could actually connect to Wi-Fi is if I connected my laptop to a router, which I don't have a spare of, and neither does Ryan have. So we just decided to scrap all of that and just do EAPOL test as like a simulated version of it. And it's fine because based on my research, EAPOL test is actually like the standard tool that FreeRadius developers use to test EAP authentication, which is like authentication using certificates. It implements the exact same EAP TLS handshake that a real wireless client would use, so the only difference is merely that there's no wireless medium or access point. So we can just directly check it. The file should be here, host AP, WPA, supplicant. And then we'll do the EAPOL test real quick. So let's test on client A first. .conf and then slash A 127.0.0.1 S testing 123 P 1812. Sorry, I messed up typing the command. Oops, my bad. I'm pretty sure it's client with a lower C. Let's test it again. Okay, yeah. See, you can see that it shows there. Where is it? Yeah, it has received EAP success, and in the end, it outputs success, meaning that it has accept client A has a valid CA issued certificate, and therefore it accepted and was properly authenticated. Now let's try on client B. Pretty simple, really. Just change this because I named it differently. So client B. You can see there it showed that it failed, right? It didn't authenticate properly, and that's because for client B, I purposely put a fake self-signed certificate with no relation to our CA. So the authentication, when it like compares the two, it doesn't recognize the certificate and therefore will not authenticate it. So the authentication fails and is therefore rejected, which is shown here in our failure output. I'm gonna show real quick the server-side logs. So, sorry, this will take a while because it's a really quite a long command, and I'm not that fast at typing things nor remember it well, so this is gonna take a while. Oops. Sure. Open SSL says error, sent access accept, and sent access reject. Root radius debug log. Okay, yes. So you can see here that, yeah, this shows basically client A's info. Ah, yes, here. So you can see here that in here, this is all of client A's info, right? And then this is on the server side, it's authenticating everything, and it outputs back accept, which means that it properly got authenticated. And I'm pretty sure it should be reject for client B, because client B was a certificate that I self-signed instead of being signed and issued by our CA. So yeah, here opens SSL says error, and the reason why is because it's a self-signed certificate. And so it rejects it. See, sent access reject. So it rejected client B, while client A earlier got accepted. See, client A got accepted because it was not a self-signed certificate and instead was issued directly by our CA. And yeah, that's all for scenario 1. Okay, so let's start with scenario 2 is domain membership validation. So let's first show that my Active Directory is installed and running, and we can see here that from Server Manager that it is active. We can also show here in the server logs that yes, the AD is installed including DNS, and as well as all 4 ADWS, DNS, NetLogon, and NTDS are all active and running. NTDS is the Active Directory database engine. NetLogon handles domain authentication. ADWS enables PowerShell AD commands, and DNS is required for the Active Directory to locate domain controllers, and it's all running as you can see here. And I can also show all the clients that are connected to the Active Directory, and you can see here you have of course the domain controller. This is my Ubuntu. This is client A, client B. This is the Radius server, and this is the antivirus server. So you can see there that both client A and client B are listed. So let's check client A. Let me check client A. This is my client A. And using commands, I can check, as you can see here, using echo user domain, I can see that the domain that it's connected to is lab. And using dsreg command status, I can specifically see exactly that yes, it is joined on a domain, and that domain is named lab, which confirms that yes, client A is domain joined on lab local, which is the domain that I set it to. And on PowerShell, I can check the certificates. So in here, this is basically like the example certificates, as you can see here. So our Radius CA is in fact trusted on this machine. You can tell from here. And by using cert util store my, which is my personal, you can see that here it says encryption test pass, which means that client A does has its own Radius issued certificate installed in the personal store, which means that this is what should get presented during EAP TLS authentication. So let's do that on Ubuntu real quick. As you can see here, I already stopped the free radius. I ran it on debug in the background already. And all we gotta do is do the eopol test again. And trust me, the certificate stuff, and it's joined on the domain and client B as well. I don't really need to show that since it's literally the exact same commands and would give the exact same. As you can see here, it's the same thing, it's success, and we can try it on the actual real like CA issued certificate for client B. Since I also created that, I created as two separate files called client B real conf and client B conf. Client B conf is the self-issued certificate, so the self-signed certificate's gonna be accepted by our EOPOL test, but this one should be because it is actually issued by the CA, so it should accept it. And we can test it right here if it oh my god. We can test it right here to see if it does accept it or not. And see, yeah, it also shows right there success, which means that yes, both A and B are recognized by the CA and they authenticate both successfully, which is the main difference between scenario 1 and scenario 2 is that scenario 2 actually uses, this time we're using an actual proper CA issued certificate, while in client B, for scenario 1, we used a fixed self-signed one. We can also just quickly check we can also very quickly check the server-side logs as well. Client cert, cert subject. My bad. I'm like very bad with memorizing these things. Client cert issuer sent access accept sent access inject root radio underscore debug 2 because that's what I named the log. And yeah, you can see in here that it shows right there. Yeah, sent access except from this is just basically local, and this is the username client B. So it accepted client B, and you can see up here as well. Yeah, sent access except client A. So this is the one from client A, as you can see here, suffix username client A, and this one same thing, suffix username client B. So they're both accepted, and it's shown in the server side logs as well. So that should be all for scenario 2. Moving on to scenario 3. So scenario 3 is file and folder privileges. So I created 3 folders, one called folder A, folder B, and folder C, with different NTFS permissions for each client. So using this command, I can check and see here that yes, there are 3 folders listed, folder A, folder B, and folder C, which were all published as SMB shares. And I can check the permissions of each folder, right, using the file path. So in here, I can see that folder A only allows full permission to client A, folder B grants full permission to client B, and folder C grants full permission to both. So by logic, if I use client A, I should be able to open folders A and C, but not B. And when I'm using client B, I should be able to open B and C, but not A. We can go test that out real quick. So let me go to client A and check it. So I can open File Explorer and I can go just, this is already logged in on lab client A. And I can just go directly to Win. And you can see there is folder A, folder B, and folder C. Remember, this is client A. So I should be able to open folder A and C, but not B. Let's try it. So let me double click folder A, and yes, I can open it. Let me double click folder B. and it should pop up an error message. Yes, there you go, cannot access folder B because we don't have the permissions to access it. While folder C I can open. That is the case because this is on client A. So now let's check client B. Let's do the same thing but on client B. So as you can see here, this is on client B. Don't worry, it is also signed in on lab client B. So logically, I should be able to open B and C. And yeah, if I double click on them, I can open it just fine. But folder A should pop up the same error message. Yes, you do not have permissions to access this. So yes, this shows that I can properly give file and folder permissions as I want. So yeah, that should be all for scenario 3. Okay, moving on to scenario 4. So for scenario 4, the objective was to install an antivirus server and deploy antivirus agents into the clients. So AV server here, I set up asset protect on-prem as the antivirus, deployed the asset agents onto all my clients. So that would be client A and client B. And you can see here there's a total number of 3 devices. All of them are okay. And if I were to go to computers, yeah, you can see here specifically there is the antivirus server, there is client A and client B. And I can manually check it. So here is client A. As you can see here, here you go, the asset endpoint antivirus is already here. So this basically same thing. So here's update, computer scan, whatever. Same thing on client B, where it's already installed. Yeah, asset protect's already also installed and deployed onto client B as well. So that just shows that it is properly installed and properly deployed. Oh yeah, I need to show that my antivirus is connected and joined on my domain. Let me go to my PowerShell. So let me just confirm that the AV server is domain joined. So first of all, okay, there you go. First of all, okay, let's confirm that the hostname is AV server. So let me go to system info and find, oops, like what domain it's joined on. And it is joined on lab local, which is my domain. So yes, it is confirmed that AV server is a domain member of lab local. So let me go to my domain controller and check the DHCP server scope. As you can see here, I already did that. And you can see that my range is from basically 100 to 200. Yeah, I configured it that way. And using this command, I can search up like what is on the DHCP server. So you can see here that there's 2 clients. This is client A and this client B. And they're on, remember that I set the range to 100 to 200. So you can see here that the IP address has been set to 100 and 101. And you can see here that my domain controller has a static IP address. So like DHCP basically makes it so that it has a dynamic IP address, which means if basically a slot is open, then it will join that IP address so long as it's within the range that I set in, that I configured. So while static IP makes it so that your IP stays the exact same unless that IP has already been taken by something else, in which case typically the computer itself will assign you the IP address. So this is a static IP. I already set it to 20, and I can show, I'm pretty sure the AV server is also the exact same. So I can do ipconfig find string IPv4 address. And yeah, you can see here it's also a static IP, but I specifically set it to 0.52. And yeah, let me just switch to client A real quick and check whether or not, like, I know that in here it has already shown that yes, this is also like 100 and 101, so it should be correct. And this also shows 100, 101. But just to be sure, I will make sure that in client A, as you can see here, that DHCP is enabled, yes. The DHCP server is the domain controller. And if I were to see what's the IP address of client A, it will say there 100 because DHCP is on. And it should be the exact same for client B. So let's go to client B real quick. Yes, DHCP server is enabled. DHCP is enabled. It is connected to the domain controller DHCP server. And it is right here. It also says there 101. So yeah, all the IP addresses have been, it covers all 4 scenarios, which was that the lab network runs on the internal network with Windows Server 2022 as the domain controller, handling the ADDS, DNS, and DHCP at .20, while AV Server runs Asset Protect at .52. And yeah, both Windows clients are dynamic IP set by the DHCP, which is point 100 and point 101. So yeah, that's all for all the scenarios.